2:30. I'm going to try to get started. I have a very long talk title. The main goal is because I don't want it to be you confused which talk you're going to. When it's long, it has to be unique. Luckily, the talk before me, which I didn't know ahead of time, we're talking about the same topic. So it's easy to summarize what I'm talking about. I'm talking about Native SSO. The audience looks a little different. A lot of people walked away and came back in, so I will still touch upon the essence of Native SSO. But because the talk before this talked a little bit about that already, I will focus more on the motivation and how to use it, the application aspect of that. So me, I'm Juan. I'm a director engineer for Okta. I lead a few teams helping build the SIEM solutions for Okta. And SIEM stands for Customer Identity Access Management. So I'll go through, mainly focus on why we wanted to solve the problem, why SSO for mobile app. Then I probably will spend quite a bit of time talking about the challenges facing the industry, especially around cookies. Cookie has been the tools we've been using so far to achieve SSO, but that's a lot of upcoming challenges happening, so I want to give you a little bit more detail. I'll talk about the solution, which is the Native SSO spec that George just talked about. And I'll have a quick 1-minute demo just to show you the experience if you want to use it. So starting with the why. We know, actually this industry sort of gets started because of Web SSO, single sign-on. Okta and a bunch of other companies started more than a decade ago because there's that pain, and we came in and solved that problem. The idea is you have a cookie that maintained in IDP. When the first web app logs in, you maybe have to enter a password. But the second web app and third web app comes in is a simple URL bounce to the IDP, and they can grant you access already. It's hugely successful. It helps us to be a professional or industry. But if you think about the achievement in the last more than a decade, we did solve the problem for the web. But for mobile or desktop app, we really don't have a good solution. A lot of companies put out proprietary solution, trying to put the different ways to solve that problem, but there's really no universal way to approach this problem. And this problem become worse in recent year with mobile exploration. There's a lot of new apps coming in the market. I own an iPhone 13 because the screen's big. I can host a lot of apps on my home screen, but I still end up having 10+ pages of apps on my phone. And if I delete any one of them, I don't know how to function anymore. That's how many apps I have. That's probably more than the number of desktop apps I have to use day by day. So I have a more native app to deal with, yet all of them are hard for me to manage. So I have to enter password on a mobile phone. The fat finger problem is still a problem. Even on iPhone 13, my finger is still too fat for it. I see the traditional when we started mobile journey, there's a lot of restriction on the password strength, mainly coming from the enterprise market. You have to have 100 characters, numbers, digits, special characters, all that. But lately, I feel like even on consumer apps, they're putting more and more constrained password strength requirements on your mobile app. So the problem is just getting worse, not only for enterprise apps. For mobile consumer app as well, you're facing the same challenge. And we definitely don't want to enter password over and over again on our mobile device. So I want to talk a little bit about challenges. How do we solve this problem? In the web world, the solution is simple. Cookie. Cookie is the solution. But we all know there's problem brewing for cookie. For people in this industry, you probably all heard about third-party cookies are going away. So I'm not going to talk about that at all. You probably know that already. But there are other cookie problems coming up that's more, not well-known problem, or you may have not paid too much attention to it. Originally, it's more of a developer or advanced user problem in the sense that we all have a lot of different browsers. cookie is only confined to the sandbox of one browser. So I have Edge, Chrome, Firefox, and Safari on my laptop. I use them all. Used to be only a problem for me because they don't share state with each other. But I'm just going to talk a little bit more detail why this problem become more prevalent, even for the average consumers. I'll start with talking a little bit about the browser constraint, browser options on iOS devices. The reason I focus on iOS is because they're at the forefront of introducing all these privacy concerns. All this trouble with cookie stem from privacy concerns, and we're gradually clamping down the capability of cookies because of privacy. And it's good to understand iOS side constraint because Android tend to follow suit over time, and these things will come over time. So I'm just going to focus on the iOS side, and this slide just give you an introduction of what sort of browser options are available. On iOS, there is that Safari browser. We typically call them the system browser. And the system browser is a separate app. Just click that Safari icon, open it up. It functions as a separate app. In iOS 9, back in 2015, Apple introduced a new way called embedded browser. So within mobile app, you can launch a new browser, and it's called the class is called SF Safari View Controller. It basically gives you ability to load the website, a full function Safari browser inside the mobile app. You have all the capability, yet it functions exactly the same as your system browser. App developer was in heaven. There's better user experience. You don't have to bounce out to a separate app and come back. You can do surfing, all of that. And all of them, the two system browser and SF Safari controller, they share cookies. They're the same browser on your device. But in iOS 11, 2017, all hell broke loose. Apple realized this is a problem. They totally changed the behavior of Safari View Controller. They no longer share cookie at all. From a backend, from anybody else's perspective, they're two different sandbox. They're two different browsers. There's no way you can remember state. So Apple knows they broke something. Specifically, they broke SSO. They know they broke what we've been striving for. And so they introduced some other browser control back in 2017. And I'm not going to talk about that because they very quickly deprecate that option in 2018. So in 2018, in iOS 12, they introduced another new control. This is still the recommended approach. It's called AS Web Authentication Session. This is their way of saying, I'm sorry, identity world, we broke you, but here's another option for you that you can still have some cookie sharing behavior. But the overall trend for the last few years is more and more constraint on cookies, and all stemming from the privacy concerns. This is talking about that newest element that Apple introduced, AS Web Authentication Session, that when they share cookie with another browser, they pop out this system browser on top of it. If you log into Facebook or other app, you've probably seen this white, pretty ugly prompt on your browser that's come from Apple. Developer has no control over it. This is Apple ways of saying, well, I have to allow some sort of cookie sharing in order to make sure the identity world still function, but I'm going to warn you ahead of time. You got to authorize. Developer should only use this for login purpose. The box, the text cannot be customized very well. You cannot say other things. So you really have to use this for login purpose. Otherwise, the user is going to say, well, this is different. I'm going to decline and won't be able to log in. So this is a busy slide just to give you a more detailed view of the cookie sharing behavior. This is a very, very detailed. So if you don't get this slide, no problem. The TLDR is very constrained today on how you can share cookie with different browser element you have on a mobile device. I'll start with something very easier to understand. This is on the right-hand column. Just look at the other browser. I so far just talked about Safari. Just for Safari alone, there's also different browser options, but there's also other browser you can install on your mobile device, like Chrome, Firefox. Starting from iOS 14, just 2 years ago, Apple introduced ability to set other browser as a default browser. So you can set Chrome as a default browser. That itself is a problem already, because customer can set Chrome as their default browser, but inside the mobile app, there's no way. You still have to be some variant of Safari browser that Apple introduced. They're totally different sandbox coming from different company. There's no way they share a cookie. So the two red boxes here on the right-hand column, just saying that it's a different browser, all hell's loose. There's no way they can talk to each other. Now let's focus on the bottom row, says persistent cookie. This is just trying to articulate the behavior on iOS when you sharing persistent cookie. If you were to use WAS, stands for Web Authentication Session, if you were to use that third control I introduced in the previous slide, introduce that in app 1, app 2, or using system browser, they can share a cookie with each other. Because Apple so far comfortable sharing that because they warn the user. That pop-up box shows up is telling the user that you're sharing cookie. So that's the behavior we know. And the other two boxes, the first column and the third column, SVC stands for Safari View Controller. That's the general browser Apple wants you to use. But when you use that browser, you're constrained with cookie. You cannot share anything. So that's the red boxes there for. Now let's look at the top row, session cookie. Session cookie behave a little bit differently. This is actually, we found it very surprising. We found it out by experimenting with it, just observe behavior. Apple documentation just promised a behavior on the persistent cookie. So the bottom row is what they promised today. Top is what we observe on session cookie. It's a little bit weird behavior. If you have a two native app in the launch browser, you can share session cookie, but they are not shared with the system browser. So you see the missing green box here in the Safari is because some weird reason they decide not to do that. All of this thing could change. The top row I talk about is not promised by Apple documentation, and Apple has a habit to change their behavior if they deem necessary. So all these things could change a couple of years from now. You cannot have cookie sharing behavior at all. All they're saying is, don't count on cookie. Maybe there are other approaches that we can leverage. Well, one more thing to make the problem even worse is increasingly we are going beyond a single device. I actually own one of each of these devices. I buy Apple stock because I pay them so much money. I assume all of you have a lot of devices as well, and you wanted to share the session between them with a single login. God forbid you trying to log in on Apple Watch with a password with 12 characters long. All the developers sort of get around today with some sort of weird sharing capability from phone to Apple Watch. But really, in the future, we should look for better way, systematic way, how people to solve the problem. The solution. I'm glad George is here, and I have a couple slides to talk about the spec, the draft spec that George worked on, and now feel very comfortable presenting it, because if you have a question, you have better expert to ask. I'm not going to answer any of that. The key is, as George talked about, is the token exchange syntax. The first flow, when first app goes through the authentication, it has this device SSO scope request, and then you come back with the device secret. And when you have the second app you're trying to log in, that device secret is your key to log in. You don't have to prompt user anymore. The way to think about it is device secret is your new cookie. It's a piece of information the backend gives you that you can share between your apps. If you think about this as a cookie, this is actually a very powerful construct, especially when you power that with client-side technology. You heard all about the passkey this week. Passkey is trying to leverage AdCloud keychain. You can use the same capability to manage this information on your device, across your different devices. There's password manager, there's iCloud keychain. All of them help you to propagate device secret beyond a single device. So I'm going to show a quick demo. The demo is just to show you the behavior that you can achieve with single login. This is going beyond the spec originally imagined. I think the spec originally just thinking about single device within device. But if you use iCloud keychain, you can share that device secret across all your Apple devices, and then you can achieve single login. What I'm going to demo is app A on phone and then app 2 on the laptop. They're totally different app, but they're developed by the same company. So I'm going to make it, do you see? I'm sorry, it's hard for me to control the browser. Basically, this is a mobile app. I launched the mobile app. There's a login button. Now I go through my fat finger problem, trying to type my username and password, login on the first app. This is a normal OIDC flow. And then request the device SSO scope behind the scene. It'll come back with the token. I also kept this device secrets on my iCloud keychain. So now I switch to Mac. I have a separate app developed. Now I click login, nothing shows up. Behind the scene is taking that device secret and logging in using token exchange syntax. I forgot to mention, if you're interested in playing around with it, there is a blog post on Okta's developer website showing all the source code for this demo. So in case you wanted to learn more, you probably better just search Google search. It's hard to see from the back. Takeaways. First of all, there is not good solution so far. George also talked about this point as well. But second takeaway I want you to take away is that understanding this cookie behavior is not only just a third-party cookie problem anymore. It's just because of device proliferation, because of privacy constraint. You can, even on the same device, you see so many instances of browsers, they don't share state anymore. The cookie syntax, where they confine into one single sandbox, is really limiting the capability on mobile apps. The way to think about native SSO is it's a powerful construct that's sort of like cookie, but there are two advantages of a device secret. Number one, it's not confined to a mobile app context anymore. You can take this within your context. You can manage that. You can even propagate across device or between your browsers if you choose to do that. The second part of the beauty of this construct is that even if you have a device secret, whenever you log into the second app, this is a part of the token exchange framework that you have to ask the authorization server for a new token. There's a lot of opportunity on the back end to build a policy to dictate how the behavior should be. You can disallow the new login or can put the time constraint, all sorts of constraints. This is a power that didn't exist when you use cookie because that was just a piece of information. Here you have information as well as a policy on the back end to control the interaction. That's my last slide. Thank you for taking the time. Love to answer questions. I lost everyone.
Question.
Yeah.
So you mentioned being able to propagate the device secret, and then it behaves like a cookie. If I'm using cookies, they're sandboxed by domain.
Yeah.
Right? So all the apps for my company on that domain,
Yeah.
they can read the cookie.
Yeah.
But other people's apps on other domains cannot.
Yeah.
What kind of protections are there to control the propagation of this device secret so that it only stays among apps that I trust and there's not read
Yeah.
and exported by somebody else?
Great question. Just repeating the question, cookie has the next property is limited to a domain. Now the device secret, there's a sort of similar construct that limits the readability only to certain domain or the developer. The answer to that story is you're left it to the client side to solve that problem. You give the control to them. In this particular demo, I used iCloud keychain, and iCloud keychain built around to make sure this device secrets are only visible to my company. I have to be signed by the same developer key. And so the two apps I demoed, they're all signed by the same developer. Nobody else can read the secret. This is encrypted in iCloud keychain, et cetera. But if you were to use a password manager, probably constraints is different. So this really depends on how you decide to manage on the client side. But you have the full power as a developer to control that. Good question.
So you're looking at setting up OIDC between the device and your identity provider there. And so if you introduce apps that are SAML enabled already, let's say, and they fail back to basic authentication, this would work with those?
Well, I'm glad George is here. The question is around whether SAML, it will work for SAML as well. Maybe George can.
So the spec the spec itself is very OpenID specific. So from a pure spec perspective, the answer would be no. Conceptually, could you do something similar with an app that was doing SAML login? Potentially, but it would take some additional things beyond just the SAML, right? Because SAML doesn't tend to give the app any ending artifact. So, you know, outside of maybe a SAML assertion, right? So if you enhanced, you know, beyond the SAML spec and said, okay, I'm going to take this SAML assertion, I'm going to send it to the back end, and I'm going to say, please give me, you know, this device secret so that I can use it with this SAML assertion on another app, then maybe you could do that. You know, I'm thinking totally off the top of my head, and I'm not sure what the security implications of doing that are, but it, you know, because OpenID Connect is sort of returning you in its flow tokens in a normal context anyway, right? It was relatively easy to provide a mechanism to provide this other value that doesn't tend to happen in a SAML flow. So you probably could enhance SAML to make it work. That'd probably be a new spec.
So you'd have to probably pass a custom attribute or something like that.
You could potentially try and shove the device secret in a custom attribute in the SAML assertion, and then, but again, I think you probably want to write that as a separate spec and think through, because the protocols are not, they're not identical. They use similar constructs, but are also different.
Advertising for George. Join the working group, then you can influence the direction of the spec.
That's right.
Thank you all. Both me and George will stick around in case you have questions.